This is a notch filter for 14 MHz. These two are for tuning the frequency, coarse tuning and fine tuning. And this is to make the notch very deep. I will show from the schematic diagram. It should in principle be possible to set it to an infinite depth. The frequency response, the center is 14.1 MHz. The upper track is standing wave ratio and the lower track is transmission. And you can see that the depth is something like 70 decibels. If I span a wider frequency range, span 1 MHz, you can see that the attenuation is 6 dB, and then there is the notch, which looks not as deep because sweep is too fast here. But 70 decibels or maybe 60, depending on how carefully one is tuning it. This is what it looks like inside. From one port there is an inductor to a connection point, goes from here to here, and then from the same connection point another similar inductor to the other port. From both ports there are capacitors to ground, and there, and from this midpoint there are many capacitors to ground, one here and 4 of them there. Together it looks like this on the schematic. Input, inductor, inductor out, capacitor to ground, capacitors to ground, and capacitor to ground. And it's 440 PF here. The midpoint here has a very high Q resonator, an inductor, and 100 PF low loss capacitors. And then there is tuning to ground, and the series capacitor and the fine tuning. So the low loss, the high Q capacitors are here, together 150 PF, and then the tuning and the fine tuning with the series capacitor here. From here to here the phase shift is 180 degrees, and by tuning this resistor properly one can balance to get an exact zero at some frequency. It's easier to see the performance here. It's just a signal generator through the notch up to the spectrum analyzer, and I can step the signal generator in steps of 100 kHz. That's the notch. So I go back to the notch here and then turn the tuning. Coarse tuning. And it's fairly difficult to find this optimum position, but I can now tune the fine tuning. And then the resistor for balancing. And you can see I could have had good new use for a better resistor than this one, but somewhere around here. And then fine tuning again will probably not make much difference. So there is a stability issue in the resistor that could be fixed. But you can see, if I go for amplitude, we can here easily see all the spurs of the signal generator. This one, and Hewlett-Packard 8657A. The high Q coil is made from copper foil about 1 decimeter wide. It's wound about 3 turns. 1 through 2 and 3 up to this point. To separate the turns, I have used bubble foil, this kind of packing material. And there is also bubble foil from here to here to keep some distance from the short-circuited turn that is formed by the outer copper foil. And then all of it is in a box like that.